Students, in this video we are going to discuss about Gauss law in magnetism, but to understand that we must know what was Gauss law in electrostatics that we have studied earlier. So in electrostatics, when we study Gauss law, it states that the surface integral of electrostatic field, that is capital E vector, over a closed surface is equal to 1 upon epsilon naught times the total charge enclosed by the surface. So let me show you. If I have a surface, right, if this is a any closed surface, I represent it by capital S, this surface enclosed a charge capital Q inside it, then according to Gauss law in electrostatics, the surface integral of electrostatic field E vector over this surface, the surface integral of electric field E vector over the surface S is equal to 1 upon epsilon naught times of the charge enclosed in it, and the charge enclosed is Q. So it can be given mathematically as the surface integral of E vector is equal to Q upon epsilon naught. This is the Gauss law that we have studied in electrostatics. But now in electrostatics only, if we have a dipole instead of a single charge, suppose if this surface capital S contains a dipole instead of a single charge Q, that means it contains a dipole, means it contains a minus Q charge and a plus Q charge separated by a small distance. So if it contains a dipole, then what will be the Gauss law? So for a dipole, the total charge enclosed by the surface S, if we talk about the net charge in the case of dipole, it will be 0, right? So the surface integral of electrostatic field over the surface S that enclosed a dipole will become 0. Means if we talk about electric dipole, then in that case surface integral of electrostatic field over the surface S is equal to 1 upon epsilon naught times of the charge enclosed in it. So the net charge enclosed in it, capital S, is 0. That means for a dipole, the integral of this electrostatic field over the surface is equal to 0. So this was the Gauss law for a single charge and for a dipole. Now come to the magnetic field. If we have a magnetic field, then it is must that there exists a magnetic dipole, because in magnetism isolated magnetic pole never exist, right? What we have studied in magnetism, isolated magnetic poles never exist. Now this shows that magnetic poles always exist in pairs. That means if we have magnetic field, this means that we have magnetic dipole. Without magnetic dipole, magnetic field can't exist, because single magnetic pole never exist. So from above equation, like if we talk about this, if we compare from this, then from above equation, for a magnetic field, the same law can be written as the surface integral of magnetic field is also equal to 0. Now in case of electrostatic field, single charge can exist. So if we have a single charge, it is 1 upon epsilon naught times of that charge. If we have a dipole, then the net charge is 0 and it becomes 0. But in case of magnetic field, we always have a dipole, monopole never exists, so this value remains 0 all the time. So this is called the Gauss law in magnetism, which states that the surface integral of a magnetic field over a closed surface is always 0. So the statement for the Gauss law in magnetism is that the surface integral of a magnetic field of a magnetic field over a closed surface is always 0. Now the reason is that because magnetic poles always exist in pair, monopole never exists, and there will, if we have a magnetism, there will be magnetic dipole and their net effect will be 0. So because of that, the surface integral is always 0. Now one more point we have to note it there, the surface integral of a magnetic field over a surface is actually equal to the magnetic flux through that surface, right? So what we have, this magnetic flux through a surface is equal to the surface integral of magnetic field over that surface. So what we can state that if this value is 0, that means the net magnetic flux through a closed surface is always 0. That implies net magnetic flux through a closed surface is 0. So we can also state Gauss law as the net magnetic flux through a closed surface is 0, or we can state it as the surface integral of magnetic field over a closed surface is always 0. There are some consequence or conclusion that we draw from Gauss law in magnetism. The first conclusion is that magnetic poles always exist in pairs which are unlike, means if one is north then other is south, which are unlike and of equal strength, so that they cancel out each other completely, right? They are unlike and of equal strength. Second conclusion is that since the magnetic flux, net magnetic flux is 0, this shows that number of magnetic field lines entering is equal to number of magnetic field lines that exit from the surface. That's why the net magnetic flux is 0. Okay, जो जितना enter हो रही हैं उतनी ही leave कर रही हैं surface को. So in that case the net magnetic flux is 0. The third thing is that there are no sources or sinks of magnetic field inside a closed surface. Third conclusion is that no source and sink of magnetic field inside a closed surface. Gauss law is all about a closed surface. We are not talking about open surface, right? So no source and sink of magnetic field inside a closed surface, or in other words we can say that there are no free magnetic charges, hence isolated magnetic poles or monopoles do not exist. There is no point at which the field lines start, or there is no point at which the field lines terminate inside the closed surface. These are the conclusions that we draw from Gauss law in magnetism. And the statement for Gauss law is that the surface integral of a magnetic field over a closed surface is always 0, or we can say that the net magnetic flux through a closed surface is 0. This is the Gauss law in magnetism. For the next video, stay tuned, stay safe and keep studying. Thank you.